To ensure the safety of lithium-ion battery energy storage systems, NFPA 69 provides critical requirements to prevent explosions caused by flammable gas accumulation. For Trina Storage's flagship product, the Elementa, a computational fluid dynamics, or CFD simulation, was performed to demonstrate how a combustible gas concentration from an event would stay below 25% of the lower flammable limit as outlined in Clause 8.3.1 of NFPA 69. The simulation uses real-world data to create a model of how gases move through the enclosure and ventilate explosive concentrations. This is done by utilizing a fire dynamics simulator for dispersion analysis. Even though Trina's UL 9548 test results show only 3 battery cells went into thermal runaway, the simulation uses 13 cells to model a worst-case scenario to create a more severe simulation. The gas release rate is set to 84 grams per minute for 25 minutes within a free air volume of 13.3 cubic meters, and the simulated active ventilation is delayed to account for a real-world detection and exhaust ramp-up time. The resulting composition of flammable gases demonstrated a maximum concentration of 16% of the LFL. Early detection of a thermal runaway event is critical to preventing an explosion scenario. That's why gas sensor selection and response time are 2 key factors to consider when designing an exhaust system. Trina Storage conducted physical bump tests to validate our gas sensor response time. When exposed to 10% of the lower explosive limit at 300 cc's per minute, the sensors responded within 7 seconds. This ensures that the exhaust system is swiftly activated if an event were to occur. When the target gas is detected, active ventilation is triggered using fail-safe louvers and an explosion-proof exhaust fan. The entire ventilation system is backed up by a dedicated UPS to ensure functionality is maintained even if all other systems are down. The time from thermal runaway to maximum exhaust takes 17 seconds. 7 seconds for detection and another 10 seconds for the exhaust fan to reach full RPM. To put it in another way, early detection and fast ventilation response time is the core of our design. Using computational fluid dynamics, or CFD simulation, Trina Storage used third-party experts to model gas dispersion scenarios using raw test data from our UL 9548 evaluations. 2 scenarios were modeled using a discrete and an average release rate to simulate one module event propagating to an adjacent module, and then another scenario to simulate constant off-gassing. Both of these models demonstrated the resulting gas concentration never exceeded a maximum threshold of 16% of the LFL, or 1.2% of the off-gas concentration. Compared to NFPA 69's limit of 25% below LFL, we were able to demonstrate compliance well below the requirement using a worst-case scenario. Detailed design considerations of gas detector response times, the use of fail-safe components, and third-party validation demonstrates our commitment to quality, safety, and the reliable deployment of large-scale energy storage solutions around the world.